Right, let me just drop a null here for the collider, and let's give it a proper name. Out grain call, and then we'll start building our new setup here for grains. Call this grain as well. Whoops. Grain, there we go. Dive in there, and then straight away object merge. Bring in that that collider. So where are you? It would be hunter post sim right here. Out grain call. There we go. So what we need to do is build, get say a lump of geometry and for them to collide with. And what I want to do is just kind of find where they actually go. Okay, so I'm just going to drop a grid. It's probably easier if I just explain as I go. So the size, I want it 7.5 by 7.5. Where's my 7.5? There we go. 7.5 size. Okay, I'm just going to template that and then look at my grid, and then let's just move it back. Or forward a bit. I mean, yeah, because they're going to be coming forward. So we need grains here and there. So yeah, we don't need grains where they are not going to go, and that's going to be because it's going to be very expensive to calculate, right? So yeah, we're going to do like a point transfer and kind of make a group or give color to wherever they go on this grid. So we need to give it a lot more divisions. Let's go 400 and 400. Okay, and we're going to transfer some color onto here. So first I'm going to drop a color and just make it all black. Oops. So then the values are 0. Okay, and then give this a color of red. Okay, and then if we do a attribute transfer, it will automatically, I think, yeah, you can see this, the grid is turned red now, so it's just picking up everything in here. But if we specify the color just to be safe and then bring down this distance threshold, you can see what's going on there. We're transferring the color information from this geometry. Now obviously we need the entire frame range here, so this is a perfect case for using a solver, right? So we're going to grab a solver, and the solver basically gives you access here. So we have inputs here. Okay, we're going to input the grid into the first input and the collider into the second input, and I'm going to Control X to delete that there, jump inside, and Control V, paste it in here. So basically we got the 4 inputs there of the solver. Okay, so anything coming in will be there. And then what's handy with the solver, well, the reason to use it is this previous frame. So anything that comes in and anything we do to it, okay, we'll have access to the previous frame state here in this node, okay, which is useful because that means we can build up information through with time, because otherwise in SOPs, on any frame, anything that you calculate on any frame in SOPs, it doesn't care about what's happened before or what's happened after, right? So this is more like a simulation. That's why it's called that's why it is a solver. In fact, I think inside here we do have a DOP network, right? So in here we're going to be doing the same thing again, transferring onto the color, okay? But after that, let me just change the size of this, or bring this down 0.25, something like that, okay? And then after that I'm going to grab a wrangle. I don't know if we'll be able to see this now. No, if we go, I think we have to go back to the first frame. Well, let me we'll just build it up first. So grab this wrangle. I think a point wrangle is fine, and I'm going to take the previous frame information and plug that into the second input, or input 2, okay, and then dive inside there, and then we need to set up a condition, right? So if the color, oops, I need to write that correctly, at CD, okay, so if the color values, we don't have to specify all of them because they're all either 0 or 100 for the red, okay, so if the color is less than the point, so I'm getting the color from the first input, in fact not the second input, so the first input, which is this, and CD here, so CD is the name of the attribute that we want, and the point is whichever point we are running over at the moment, ptnum, okay, so I'm comparing the color of this with the color of this, which is the previous frame, the color of the previous frame, right? So if the color of the previous frame, of the current frame is less than the color of the previous frame, then we will do this, right? We will set the color to red. Just like that, and that should work for us, okay? So if we scroll forward now, we won't see it in here, but if we come out of the solver, it will calculate everything for us. So it's a good idea to drop an output in these solvers, because whatever I leave if I do that, then it will still this will still be processed up to here, okay? So if we come out now, we should see the results of that working. Can see that took a bit of time, then we get this blue line, which means it's calculating. So now you can see the red stays where he was walking before, and you can see it's taking a bit of time because it's running through this each frame. Okay, so what we can do is just drop a time shift just to freeze that at the end, which is 250. Let me delete that. 250. So you can see that will calculate a bit until it gets to the end. Okay, and then we will, oops, delete it. Let's see. Yeah, so we'll delete it by the color, right? So we're working over the colors on the points, so we'll delete them, and we'll delete by expression, and then just say, oops, at CD is more than 0. So anywhere where the color is not black, it will be deleted, and we just do delete non-selected, and that isolates this area that we can generate grains with.